Hello everyone, my name is Lisa and I'm glad to see you all at Winter Data Meetup organized by DataZen Community and Community Day. Meet Beni Gal-Janko, an expert in cloud-based big data solutions, ready to show you how to master data lake federation. Learn how open source tools like Apiary, Beekeeper and Waggle Dance make managing data across environments easier and more efficient. Before we jump into our session, I would like to take a moment to ask for your support in growing our community and recognizing our incredible speakers. If you are enjoying today's discussions and want to stay updated on upcoming events and talks, please take a second to hit the like and subscribe buttons below. Your participation not only acknowledges our efforts but also helps us reach a wider audience, allowing more people to learn from these insightful discussions. Also, in the video description, you will find a link to the talk page where you can share your feedback, award the speaker a badge, and rate the session. Your input is incredibly valuable. It helps us improve future events and ensures our speakers get the recognition they deserve for their hard work. Additionally, we would love to hear from you throughout the talk. If you have any questions or insights, feel free to drop them into the chat. Our team will be actively monitoring and we will gather your questions for the Q&A session at the end. Your contributions make the discussion even richer, so don't hesitate to participate. And now, let's welcome our speaker to share his valuable insights with us. Beni, floor is yours.
Thank you very much. Hi, good morning or good afternoon, everyone. Maybe even good evening for some of you. Nice to meet you all remotely. My name is Beni and I am from Cluj, Romania. And I would like to talk to you today about mastering Data Lake Federation using open source tools. Just a few words about myself. My primary skill is DevOps on AWS. I work as a software development engineer and I am specialized in designing and maintaining big data tool sets on AWS. The scripting language of my choice is Python and I write all infrastructure as a code in Terraform. And today I am honored to present to the DataZen community, so big thank you for joining today. About the agenda of today's presentation, in the first part, I would like to speak about these tools that I brought to you. Then, in the second part, I will explain a modern data processing tool that I developed as well, that can be used on the AWS cloud for data processing on raw data. Then at the end, we will reserve around 10 minutes for any questions that you may have. Please send them during the presentation. How many of you used any on-premise or any cloud data lake by now? Maybe you can comment under the live stream as well, so I can get a sign back from you later. I believe quite a few people, and what a data lake is actually, by definition, is a centralized repository that allows you to store all your structured and unstructured data at any scale. You can store your data as is without having to first structure the data, and you can run different types of analytics, from dashboards and visualizations to big data processing, real-time analytics, and machine learning to guide better technical decisions. The issue with on-premise data clusters is that it can happen that you say that, great, I want all of this on cloud from now on, as cloud is becoming more and more popular, obviously. Then you have to migrate your local clusters to a cloud provider. If that happens for multiple clusters, question is how to manage everything together in a single and unified data lake. I have four main tools as solution. I will show today Apiary, Beekeeper, Waggle Dance, and Circus Train in more details. Then we'll proceed to the data transformation tool with Batch and stream processing. If you noticed, we have tools named here related to bees and hives. By any chance, have you worked with Apache Hive before? Again, please comment below so I can get a sign back. I believe that these really work because, by the way, I have seen managing almost 5,000 petabytes of data on AWS with these tools, and that's a lot, believe me. And that's also a lot of responsibility as well, where you need some really proven tools that can support you with your data lake. So if you work with Apache Hive, then this will sound good to you because the first tool that I brought to you is built on the top of Hive, Apache Hive, and it is called Apiary. An apiary is, by the way, a location where beehives of honeybees are kept together. And this tool will be the base of our federated data lake. So what is Apiary? It is an open source project, basically a set of Terraform modules, which can be combined together to create a federated cloud data lake. And these sub-modules include, I will explain the most important ones. First and foremost, a read-only or a read-write Hive metastore service, HMS in short. Waggle Dance, the federated metastore service, which we will see in details. Also Beekeeper that we will see. It's an event-based data lifecycling service. There is another component called Dronefly that decouples the Hive metastores event listener implementations from HMS. And we have all related infrastructure, including load balancers and container deployments for AWS as Terraform code. We have also various extensions, plugins for additional functionality to the HMS. I would like to mention other subcomponents as well, because there are a lot. Just briefly, these, so you can see the power of the tool and that it was carefully crafted to serve enterprise level needs as well. So these are all other sub-repos of the Apiary project, like the authorization module, which defines Apache Ranger deployments together with Solar for access management. Maybe you have used Apache Ranger before. As I said, there is the Dronefly, which allows to deploy metastore listeners outside of the Hive metastore service. There are a lot of other extensions for metastore event listeners, event handling, metrics, Hive hooks, etc. There is a few subcomponents for the deployment scripts, like for Beekeeper, for the Docker components, metastore Docker as well, for Ranger separately, for Waggle Dance separately. So all of these word out. Good. So the Apiary data lake module, that is, let's say, like the biggest one. This is the Terraform module that defines the deployment of various stateful components in a typical Hadoop compatible data lake in AWS. I will just briefly mention that what you can see on the architecture diagram, all of these are managed by this Terraform repo. So there is an Aurora DB cluster to read and write metadata separately, reader instances, writer instances. There are the actual highly available backends for read-only and read-write metastore instances separately. This is implemented as an ECS Fargate cluster on AWS. There are the load balancers, again, separately, read-only and read-write endpoints provided for consumer and producer access. There are the S3 buckets, which are all managed by this to be provided as parameters to Apiary. And these hold all the actual data. As I said, the metadata is on Aurora, the actual data is on S3. And there is all the other infrastructure to run processing and analytics on everything. Yeah, so the users can access, run their ETL jobs, things like that, a lot of nice things. Yeah, so this is Apiary and the Apiary data lake module specifically. Next, we have to guard the data in our Apiary, right? And for that, we need some life cycling of the data. And for that, now we have a Beekeeper, our life cycling guardian. Beekeeper, in short, is a service that schedules orphaned paths and expired metadata for deletion. It uses one of the extensions mentioned previously, the Apiary metastore listener, that captures Hive events and publishes these as messages to an SNS topic. Beekeeper uses these messages to detect changes to the Hive metastore and to perform appropriate deletions based on some rules that you can define. It is comprised of basically 4 separate Spring-based Java applications. Let's see these. There is the scheduler API, an application that schedules paths and metadata for deletion in a small shared database, with one table for unreferenced paths on S3 and another for expired metadata in Hive. There is the path cleanup, a small application that performs deletions of unreferenced S3 paths. There is the metadata cleanup application, very similar, that performs deletions of the expired metadata. And we have an API as well, a REST API actually, that allows to see what metadata and paths are in the shared database, scheduled or historically removed. You can see here the architecture of Beekeeper and how it is deployed on AWS. We have our data lake already nicely deployed. And for that, if you remember, we said that we will deploy the optional API metastore listener that will listen to all the changes that we have in our Hive metastore. There will be a queue, actually an SNS queue on AWS, that will receive all those messages, changes coming from the metastore listener, and will push to our API receiver, which will be pushed further down to our scheduler API Beekeeper component. This is analyzing all the changes in the API based on the rules that you set. It will be able to schedule a deletion, like you want to keep only 30 days in a table worth of data. You want to remove orphaned paths on S3 that are not referenced anymore. You can set all of those on your tables in Hive, and Beekeeper scheduler will recognize based on those rules what should be scheduled in the small database. Good. Metadata cleanup and path cleanup applications will come and see in the database that you have a new schedule for a metadata or path cleanup. They will just execute those. We'll go to Hive to remove things. We'll go to S3 to remove nicely. We'll execute the cleanup nicely, and we'll update the schedule that it was completed in the Hive and S3 locations. You will be able to query with the Beekeeper API these to see what happened, like for an audit log. Good. That was Beekeeper, and let's move on. You know that honeybees explore fields in nature. Then they go home and tell the story to the other bees where the nectar and pollen is located as data. This storytelling is called Waggle Dance scientifically, and in our big data world, we can use Waggle Dance as a tool to federate data lakes, like telling data consumers and data users where the different data lakes are located in our cloud or different clouds. And this serves as a metastore proxy to all those remote data lakes as well. So Waggle Dance as a tool is a request routing Hive metastore proxy that allows tables to be concurrently accessed across multiple Hive deployments. It was created to tackle the appearance of dataset silos that arose as large organizations gradually migrated from monolithic on-premise clusters to cloud-based platforms. In short, with Waggle Dance, I provide a unified endpoint with which you can describe, query, and join tables that may exist in multiple distinct Hive deployments. Such deployments may exist in disparate regions, different accounts, or even different clouds, if you want. Dataset access is not limited by this to the Hive query engine and should work with any Hive metastore enabled platform. For example, I have been successfully using it with Spark. I also use Waggle Dance to apply a simple security layer to cloud-based platforms such as Qbol, Databricks, and EMR on AWS. Unfortunately, these other third-party tools currently provide no means to construct cross-platform authentication and authorization strategies. Therefore, I use a combination of Waggle Dance and network configuration on AWS, for example, to restrict writes and destructive Hive operations to specific user groups and applications. So that is very useful together with Waggle Dance. Also, Waggle Dance maintains a mapping of virtual database names to federated metastore instances, and these virtual names are resolved in the background by Waggle Dance during execution, and requests are forwarded to the mapped metastore instance. But let's see actually, you can see here a very simple architecture diagram of Waggle Dance. Again, we have here our federated Hive instance, and Waggle Dance is deployed in the front, everything, to handle incoming metastore queries to its federated endpoint. We have here, for the primary local metastore, even multiple ones, it's not a problem, a proxy database that will just route to our local here all queries which are queries made by the users to this metastore instance specifically. But what happens if a query comes, which is actually a database, pointing to a database, which is in an external cloud? For example, we have these virtual databases inside Waggle Dance, and it will just see, okay, the user wants to query something from a foreign database. It will just nicely route in the background to metastore X or Y to those concrete databases, the queries very nicely, seamlessly, without the users noticing that a proxy call was made. So that is how we create our big federated metastore instance as a federated data. Good. Let's move on to our fourth tool. And you can face situations where a lot of data has to be copied. And it may happen even between different Hive metastores. And you want a reliable way of replicating data, right? There comes into the picture the tool named Circus Train, a data replicator application. And seemingly, I do not have for this a bee-related name, but maybe it will have in the future. Sorry about that, if you like bees. So Circus Train is the next open source, a containerized Java application that replicates Hive tables between clusters on request. It replicates both the table's data and metadata. Unlike many other solutions, it has a light touch, requiring no direct integration with the Hive's core services. Circus Train can copy either entire unpartitioned tables or just a user-defined set of partitions from a partitioned table, for example, multiple partition tables. The application is compatible with any Hadoop file system, and there are a lot of features like snapshot creation, fail-safe replication. You can do table and database renames during copying. Maybe in the target you want a different name for the table rather than the one in the source. You can do table attributes control, so you can copy different attributes. You want to keep some, you can add new ones maybe. Very important that transport encryption is present, and it is very important as it can happen that you want from the source to the target to copy PIY data, which is sensitive data. You must encrypt that between the source and the target tables. And it is seamlessly supported by Circus Train. Circus Train will provide metrics about replication to see how much data you copied. It has event listeners, even pluggable transformations during data copy if you want to be very fancy, etc. Configuration can be provided using YAML, property files, environment variables, and command line arguments as well if you want. So yeah, that was the fourth tool. To summarize, you can find these tools on GitHub as open source projects. And we discussed Apiary, the base of the federated data lake. We discussed Beekeeper, our lifecycling guardian, to not have unnecessary data kept in the cloud because that can cost. So it is really important to lifecycle data and optimize costs by these. We have Waggle Dance, our metastore proxy, which is for creating the actual federated data lake between different clouds even. And we have a tool called Circus Train, our data replicator, which is used to do enterprise level data copies if that's needed between even different clouds. Good. Next part of the presentation is about another tool that I'm bringing to you, which is about how to transform a lot of data with batch and stream processing. It seems to be an interesting and proven tool that maybe you can learn from as well for your personal projects. For context, this service executes essential data transformation from a lot of data streams. You can lend a lot of data daily. like even a few petabytes of raw data as well. And if you need to ingest data from tens of different data sources, then batch the data processing, but also real-time data processing can be needed as well, in my opinion, and based on my own experience. You can decide that you will not develop a full ETL pipeline for each data source, but instead you develop a service like that I'm talking about with the goal of enhancing the accessibility of these data sets within the data lake. About the technology stack, I personally deployed this on AWS using EKS for container orchestration, but you are flexible to use ECS if you want, or other container orchestration platform as well. I used again, of course, the S3 and Hive for metadata and actual data storages. And coding was done in Java, and I have Apache Kafka for the streaming part later. For the batch processing, this is the architecture diagram of the service that I created. And on the left-hand side, data comes into the stream platform through a previously set up stream from a data producer app. You can already see a few components here. You can see Kafka, and I have a Kafka agent. So this is like a custom application that I implemented with Kafka. Kafka Connect is here, which is used to move the data from the stream directly to the S3 storage. You can also see something called the control plane. This is the point used by, let's say, the consumers of the data to interact with my service. And this is the place where the consumers are actually configuring the imports and transformation that they want to apply on the data. And other than that, yeah, you can see on the right-hand side, the Hive zones there. First, we have the landing zone in which we are bringing in the data unprocessed from the stream. So we are taking it directly as it is, fully raw. And you can also see something which is called the master zone. So this is like the layer from which the consumer is actually using the processed data. Going into how everything works, we will start from the control plane part. As I said, this is the way the consumers of the data interact with the service. They would put here like a JSON configuration related to the source from the stream part. And also a configuration for the target, where to put the data, things like that. So defining from where and to where to put the data in the master zone, and how they want to do that also. I have the Kafka agent, which basically scans the control plane periodically, and as soon as we get new events from there, or things like scheduled imports that need to run, it's going to trigger the Kafka Connect component, which is going to transfer the data into S3, as I said. At this point, it is important to say that the data is transferred in Avro format because it's more efficient and it gives you some speed when writing the data. From there, we have the Hive agent, which also reads data from the control plane, which again scans the information that we are getting in the Hive landing zone. Based on that, here we also are playing the transformation part with my process. So I don't know, maybe you want to mask some data, or you have some ideas that you want to bring to a standard format, like, I don't know, 9 digits from a string, things like that. And after processing, those transformations happen, we are actually dumping the data in a Parquet format to the master zone. because most of the time consumers would like to select some specific columns, and Parquet is better suited for them. And from a performance point of view as well, it is much better in this stage. One thing to add here, so you can notice on the diagram, I have some delays noted. So each zone, it's actually running on a scheduled way, and basically every hour we are checking the control plane and putting the data in the landing zone, and then the same schedule of 1 hour applies for the master zone. So if you would be in, let's say, not that good case, then you can have like up to 2 hours of delay before you are getting the data. Okay, so now some things to consider related to this batch processing part. So as I said, it's a multi-step process. So you have that delay, but that also gives you some value in the fact that we have the landing zone. Let's consider, for example, the use case in which you want to change the calculation for something like a number value with a different formula from now on, let's say. You are able to reprocess all your data and actually backfill that new value for all the past values and all the past data from the landing zone. Let's consider like a data science context in which you need to train your model and you need like a lot of history, okay? So you can do that to retrain with different data, different formulas maybe on the data. And also cost is something to consider here. So everything that I just showed to you runs on a big Kubernetes cluster with a very lot of high performance nodes, and yeah, that increases the cost a lot. And also there's the landing zone, which has a disadvantage as well, because you are basically duplicating the data. So it's going to cost more to have it there on AWS S3. And also, this is, I guess, like a classical issue with the streaming context. You have to do data deduplication based on some unique identifier that it's set during the configuration part. Those would be the things to consider for the batch processing. Now, moving forward to the streaming context of this service. So the architecture is the following for the second use case. As you can see, this architecture is definitely lighter than one of for the batch processing. So I'm using less components in here. The logic would be like this. We still have the same control plane as in the batch processing case. It's the same way of interacting between the consumers of the data and our service. This time I have a streaming agent, which basically has a similar role to the Hive agent seen on the batch processing architecture. So it just scans for everything that would be set in the control plane and then would send that information to an application, which we are calling data persister. So basically, you would get some information about the data that's in the streaming platform, and right away you will start to consume that data, and this time actually write the data directly to Iceberg tables. Iceberg tables are an open source type of table. It's actually very efficient in this use case for streaming data. And it's actually even more effective cost-wise because it consumes less storage than Avro and Parquet in the use cases that I have to implement here. Okay, and again, we have Hive used to expose the data to the end user. A few things to note here: being in a streaming context, you don't really have the chance to actually stop everything and, I don't know, do things like schema extension. Schema extension is something that I can manage automatically, and it works just for adding new columns, for example. So if someone decides to wrongly modify a column uh, across the line, it's not going to work Yeah, you need manual intervention, unfortunately, in this streaming process way. But when it comes to new columns being added, everything gets dealt with automatically, as well, things like partitioning and so on. Again, some considerations related to the stream processing. So the data is written directly into the target, as I mentioned. You have the advantage of not having the landing zone, so less cost, but you also have the disadvantage that we are keeping the data in Kafka just for 14 days. Normally, I think this should give you enough time to update your processes or tables if something fails, because realistically, the only thing that could go wrong is if the database schema is changed and it's incompatible with what you already have. So normally it should be something that you could address in less than 1 day, I guess. And also related to cost, as I mentioned, I am using iceberg tables, and this is more cost effective. And again, the part that we don't have any landing zone that reduces the cost. So another thing related to the retention set to 14 days. So remember the use case that I mentioned for the batch processing, in which you could recompute all the data if needed. Here you actually cannot do that unless the data is built in a way that you also have like the source column based on which you did the computations in the final. Then this is a configuration example I created for the processing tool myself. This is the way that I actually configured an import for the service. As you can see, we have the source and target definition, the source table, source DB, target table. And also this is the part which you can in which you can define the transformations, and the way that you are writing it is just plain SQL style, for example. I also have a deduplication logic which needs to be set. As I said previously, it's very important. And so, as I was mentioning, this is a classic problem when it comes to streaming. So we need a unique identifier of each row to be able to apply the deduplication while I am transforming the data. Good. That was it for the batch and streaming tool as well, with which you can process data and transform data. That's all regarding the tools. I just found some open source implementations of these on the public internet. And I would like to mention our partners, the Global Cloud Hub community, and also the data storyteller community as well. And that should be all from my side today. We reached our Q&A session now. So if you have any questions, I would be more than happy to answer them.
Yeah, thank you, Benny. Yes, we have questions for you. So the first question is, are these tools designed to work together, or do they can serve separate purposes?
Mm-hmm. Very good question. You can choose, as I said at the beginning, the API is the base of our federated data lake. That is kind of the mandatory part from which we start our data lake. And the others are optional. You don't have to use Beekeeper strictly necessary, or Waggle Dance if that's not needed for your purposes, or Circus Train. These are separate tools. API is the main one. But if you use them together, you can do that. They work seamlessly together.
Okay, got it. Thank you. The next question is, do I understand correctly that all these functionalities can be implemented with Databricks, but mentioned tools are open source?
Yes, so these are open source tools, and it can be used together with Databricks as well. As I mentioned, Waggle Dance is able to apply an abstraction layer for that.
Okay. Are these tools ready for prod and really big data? What's about scalability?
Yeah. First, regarding scalability, thank you for the question. All of these are implemented to be able to auto scale if needed. Waggle Dance is implemented like that. Beekeeper as well. Apiary on the architecture diagram, you could have seen that the HMS, the Hive metastore, is deployed by Apiary in a way that it is fully scalable. You can configure your auto scaling groups. And yes, this is ready for production on my personal implementation. I found this really useful for production ready usage.
Great. And how often is this actually used in production? Can you share real world examples where these tools have been successfully implemented?
Yeah, I'm having my own hobby project where I did this. What I have seen, I cannot mention anything specifically, but maybe reach out to me separately, and I will be able to find some actual real life examples for that maybe.
Okay. Next question is how to learn these tools and what knowledge is needed to start?
Mhm, mhm. These tools that I presented to you are available on the public internet on the open GitHub, and on the in the READMEs there are in the repositories of each of these very detailed explanations how to configure these, how to deploy these, how to use these. So yeah, it is easy to learn.
Great. And the next question, is it necessary to learn this if there are many cloud services that can do the same?
I think it is a better choice to use these because Apiary, the base of our federated data lake, um, handles all those AWS services in the background. It is a good abstraction layer to not learn too many other services,
Mhm.
and you can learn one or just these four at most that I mentioned to you, and these work seamlessly together, and you don't have to do the integration. If you need to federate multiple data lakes, you have it here with Waggle Dance, seamlessly deploy, configure it for your specific use case, and I think it's a much better choice than to learn other services out of this ecosystem.
Okay, it makes sense. Yeah. How to deploy these tools in cloud? Are they ready to use deployment scripts?
Yes, yes, of course. So, for example, if you go to the API repository on the open GitHub, you can see a specific deployment scripts there, a containerization part for your builds. You can quickly put in your CI and CD environment the builds of API, the containers can be pushed to your artifact repository, and there are specific scripts for the deployments of each tool, so it should be easy to follow those readmes, and deployment scripts to run on any platform, I think.
Okay. Are they deployed on EC2? And what about cost?
Yeah, so if you have at the beginning a small data lake, it will not have to be cost, in my opinion, and it should be yeah, it is EC2 based, but you can choose there if you have chosen EKS to run, then it just depends on your capacity needs to deploy as many EC2 nodes for your Kubernetes cluster as needed. What I just can tell it is uh, in my personal opinion, carefully crafted to be very efficient and to not use more capacity deployed as needed for your calculations for your storage.
Okay. What open source tools you recommend to handle this stack of for data governance of such federated data lake?
For the data governance, yes. So as I said, Apiary can deploy Apache Ranger for you, Solr for permissions management, access management based on security groups to supervise everything, to make audits, and that is part of the Apiary ecosystem. I just did not have too much time for the authorization module to go into, but there it is.
Okay, and it was the last question. So thank you,
Oh,
Benny, for the presentation. Yes, thank you everyone for joining today's discussions. In the description, you will find a link to access the presentation file and recording. Don't forget to say speaker thank you by awarding a badge and rating the talk. Be sure to subscribe to our channels for more content like this, and we hope to see you at the next session of the Winter Data Meetup. Bye bye.
thank you. Bye.